All right, guys, welcome back. We're going to do our part 3 video of lesson number 2, and this video is on our friend, the intermediate value theorem. I just want to say right off the bat that we will never write intermediate value theorem on any paper or anything like that. We're going to just know it as our friend IVT. So in calculus, when you're doing free response questions, you can abbreviate a lot of words, a lot of symbols and stuff like that, and the theorems are no exception. So intermediate value theorem, from here on out, I'm going to say is IVT. Now, IVT sometimes students struggle with initially. It's a really simple theorem. And what I always tell students is that the definition that calculus gives sometimes can be very confusing. So I'm going to read it to you here in a second, and then I'm going to show you example 8, and then I'm going to come back to this and kind of clarify a little bit what this is, because sometimes these things can be very confusing if you're not sure what the theorem's actually saying. But the first thing I want to say about the theorem is that notice the very first thing that said, is it continuous on a closed interval? All right, it has to be continuous on that closed interval. It has to be, and so that's why it's in this lesson. As we just talked about continuity in the second video, it's if f is continuous, and it has to be 100%. And if k is a number between f of a and f of b, then there's at least one number x between a and b such that f of x is equal to k. So again, you look at that and they're like, what is happening here? So let me do example number 8, and then I'm going to come back and kind of explain this to you. I will tell you that when you explain your IVT, it is pretty wordy. It's the only theorem that requires a good amount of explanation. And so again, when I write out the explanation for IVT, this should make more sense to you. So let's look at example number 8 first and foremost, and it says that I want to show that my function f of x, right, and it's a cubic function, and I don't know what this graph looks like, right, exactly. You know, I know it's a positive cubic function, so I know its end behavior is going to look something like this. I know it's going to be at -1, right? I know that the y-intercept's at -1, but that's really kind of all that I know right now. I don't know if it's going to go like this or if it's going to go way out like this, so I want to show that it's going to have a 0 on the interval from 0 to 1. So what that means is that I know, well, first of all, I know that it's going to hit at -1, right? I know it's going to hit because that's the y-intercept as at -1. I want to show that it's going to 100% cross the x-axis between 0 and 1. All right, so what do we do with that? Well, let's go talk about this. Well, you notice that we see here an f of a and f of b. Well, this is our a, and this is our b, and we've actually already discussed that in our little theorem right there. So let's find what these values are. So f of 0, right, f of 0 is going to be 0, 0, -1, right? So it's going to be 0 plus 0 minus 1 is -1. And we've already defined that right there. We automatically knew that. And then f of 1 is going to be 1 cubed, which is 1, plus 2 times 1, which is 2, minus 1, and that's going to give us 2. So I know that f of 1 is going to be here at 2. Remember that this is a cubic function, and it's also continuous, which means that when I'm going to plot this point, if I'm going to go from here to here, I have to do a continuous thing. So I can go down like this and come back up. I can do this. I could do possibly this. But the whole point of this, I can go and do something like this, right? But the whole point is that I'm hitting this axis in between 0 and 1. It has to happen. In order to connect from this point to this point, I have to cross this axis, right? I can't go around like this and do it because then it's not a function, right? It won't pass a vertical line test if I do something like this. So that's really all that is. So let's go ahead and justify what we do. I'm gonna get rid of all that crazy stuff because that looks a little bit insane. So again, I'm connecting my points, something like that, right? And so this value here is the k, which again, I'm not going to try to confuse you guys. I like to use c, so it's my c. So now we have an idea of what that is, right? So let's talk about what this now means. So this is the explanation for IVT, and it's very wordy, and I apologize now for saying that. So we're going to write out 4 conditions, and I'm going to use 4 different colors to talk about that. So the first thing is that since f of 0 is equal to -1, and that's less than this value here, 0, which is less than f of 1, which is equal to 2. Okay, so all that just means is that I have a value here at -1, I have a value here at 2, and so this value has to be in between these two numbers, right? I have to go from negative. Well, think about it like this. If I'm at -1 and I want to go on the number line and I want to go to 2, right? We're walking the number line and we want to go to 2, we have to cross 0. We have to. If it's a continuous function, right? We have to cross 0, we have to cross 1, 1/2, 1/3, all that stuff. So all this is saying is that since I'm at -1 initially, right? At A, initially we're at -1, we're traveling on our function till we get to f of b, which is at 2. So we had to go through 0, that f of -1 less than 0 less than f of 1 equals 2. So we're going to say this, and f of x is continuous. You have to say that, because if it's not continuous, then you could have a piecewise function, you could have something removable, you have a hole right here, you could have it jumped, so you have to say that's continuous. I am so sorry that's how that's written. That is supposed to be the word continuous. All right, so that's, I told you there's 4 parts. The first one is the fact that this number here is in between these two values here. So this right here could have been anything between -1 and 2. It could have been a 1/2. There's a solution of y equals 1/2, or -1/3, something like that. All right. And again, I'm going to try to do a little bit more explanation, a little bit of time. So okay. Then you're going to say by, and then by, by IVT. So you have to always say in calculus what you're using. There exists some c, and that's going to be right here. I don't know where it's crossing. I don't know where it's crossing between 0 and 1, but it's some c on the interval from 0 to 1, right, on the interval. And you don't have to say continuous because you've already said it right there. There exists some c on the interval from 0 to 1 such that f of c is equal to 0, right? And this is the k value that we were looking for right here. So f of c is equal to 0. So we don't know where it's going to cross the x-axis, but we do know that somewhere between -1 and 2 on this continuous function, we can conclude by IVT that there's going to exist some c, some value between 0 and 1, right, between 0 and 1, that's going to cross the axis where my function is going to be defined at y equals 0, right, which is just a 0 in the function. So we're going to do another example of this just so you guys can kind of see what's going on with it, but that's the kind of clarification for that. Before we get to the next example, I just want to show you guys a little bit of just, all right, let's think about it in terms of real life, because a lot of times it makes more sense to students if you can kind of think about, okay, how does this relate to real life? So intermediate value theorem really is just something's got to be continuous over an amount of time. So if you think about example A here, it said, well, first of all, the question says, determine if IVT applies in each problem and then explain your answer. So it says, currently your height is 9 feet, 5 feet 9 inches tall, right? At some time in your life, you were 3 feet tall. And so we know that this has to be true. It has to be true, and we know this by IVT because height is continuous. It is continuous, right? You start out a wee little child, and then you grow, and there's always a time, even if for just a short period of time, you had to be 3 feet. Even for a 1 day, you had to be 3 feet. For 1 second, you had to be 3 feet, right? You had to be 3 feet. Another good example of IVT is when you're driving on like the interstate, like I-66 or around the Beltway, and you are at 65 miles per hour, right? You look down at your odometer and you're 65 miles per hour. There at some time when you got into your car to start it up and driving around the Beltway that you were going 55 miles per hour, 57 miles per hour, 61 miles per hour. You see what I'm saying? Like, that's what IVT is. It's just, that's all it is that if it's a continuous function, then you had at one moment in time had to be everything in between those two values. So for example, 9b, it says at halftime, the Bruins basketball team has 36 points. So there had to be a time in the first half of the game where the team had 25 points. Now, this, and if you don't know basketball, then you may not be sure about it, but this is clearly a false statement. And so we could look at a time where the Bruins had 23 points, right? And then someone on the team shot a three-pointer, and then that means that they went up to now 26 points, right? So they didn't have to have 24 and 25. And so that's why this is not a continuous function. So IVT does not apply here. Does not apply. Okay? Because again, scoring in basketball is not a continuous thing, right? So hopefully that makes sense. I'm going to do a couple more examples now of IVT. If my BC notes, this is all that I've given them, but because of videos, and if you're still not clear on IVT a little bit more, I want to do 2 more examples. So I'm going to pull 2 examples from my Calculus AB class. All right, so let's do them. All right, so I went ahead and pulled 3 more examples for us to look at for IVT. And so I wanted to give you guys an example where it's not a root. So this says, given the function g of x, which is equal to 10 sine of pi x over 4, prove that g of c equal 5 for some value c on the interval from -1 to 1. So I'm going to do this one a little bit different and hopefully makes more sense to you guys of what we're going to do. So the first thing you always do for IVT, and if students don't really understand what's going on, you still, first of all, just want to go and plug in and see what's happening at our initial. Like, where are we on this function when x is -1? So we're going to go ahead and plug -1 in here, and we're going to get 10, we're going to get sine, and we're going to get negative pi over 4. Okay, negative pi over 4. So if we look at this 10, so this is where our trig values come into play, right? So sine of negative pi over 4, and we're now in quadrant number 4, right? We're moving down here, and sine of pi over 4 is the square root of 2 over 2, but because we're in quadrant number 4, sine is negative there. So we're left with negative 5 square roots of 2. So what I want to do over here to the right is I want to graph. So at -1, we are at -5 square roots of 2. So I'm going to show you guys hopefully now a better example of that. So at -1, our g of x, we start at this value of -5 square roots of 2. All right, let's continue on with the next example. And we're going to now do g of 1. Okay, g of 1. And that's going to be 10 sine of, and we're going to plug in 1 here, right? So it's just going to be pi over 4. And that's going to be equal to 10 times positive, because we're in quadrant 1, clearly, square root of 2 over 2. And that's going to give us positive 5 square roots of 2. So then what this means is that if we're now at 5 square roots of 2, we're over here now. So we're at this value. Now remember, we're on the interval from -1, right? So our graph is in between -1 and 1. And we have to have a continuous function. We have to have a continuous function, right? So we have to connect those 2 dots. Again, we can come down like this and all the way up like that. We can go all the way up like this, and we can kind of start oscillating like this. But we have to be in between these 2 lines. I always tell students we have to stay inside the house, but we can go up and down we can go up and down the floors as much as we want to, right? We can go in the basement, we can go up in the attic, or we can stay in the main floors. But we have to be able to connect these 2 dots in some continuous function, right? We can't do something like from this point to this point. We can't go and do something like this because, again, it's not a function now. So we can't do that per se. So what that means is this. So now let's look at this line for g of c equals 5. Well, this is 5. And so this is my line, g of 5. And so all IVT says is that there's a value right here. I'm sorry, this is getting so small, but there's a value that of c, f of c, where my y value is 5, because 5 is in between these two numbers, right? Anything could have done this. You could have said g of c is equal to 3. Anything in between these numbers. This number is going to always be in between these two things. So that's why when we started talking about how to write things out, like when I started writing stuff out for you guys, I said since, right, our first step, since f of -1 is equal to -5 square root of 2, and that's less than 5, which is the value we have here, which is less than 5 square root of 2, right? And we can also say that g of x is continuous. We have to say that, okay? Because we could easily have a jump here. And then you say by IVT, you can say that there exists a value c, right? Which again, we don't know where it hit the x-axis, but we know there's some value c here on the interval of -1 to 1, such that whatever that g of c is, it's got to equal 5. All right. So this is one of those theorems where, you know, I spend time outside of class going over more examples or more things like this. But you just have to understand that we're starting here, we're ending here. We have to go through every single one of these y's, every single one of these y values until we get to this. So again, this number here is always going to be in between these two numbers. Always. If it's not, then either you've done something wrong algebraically, or the question's written poorly, which is not the case, or it's not IVT. Okay, it's not IVT. So I'm going to move on from this question. I hope that this makes sense to you guys. If not, then you can talk to me again on we start up school and office hours and stuff. All right, so sometimes the questions are not going to be exactly like, you know, show that there exists some value, blah, 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 on an interval. Sometimes you see something like this. The function f and g are continuous. So again, really important that that's continuous. So you know that there are other theorems clearly that's going to be in this class, mean value theorem, Rolle's theorem, but IVT is the only one. Well, they all deal with continuity. So, you know, we got to kind of go through these questions, see what's going on. But it says the continuous function is given by this function right here, this composition. The table of values is given below. Explain why there must be a value t on this interval, right, on this interval. Now, a lot of students are like, you know, well, it's not closed, but we're going to assume that it is closed. All right, so it's going to be on a closed interval such that h of t is equal to -1. When we start talking about the mean value theorem, which is way far away from now, this would be a derivative. So I will tell you guys, we will probably do this exact question again much later in the course, where it's the same word, the same words. The only difference is now it's h prime of t. That completely changes the problem. So what's my point here? You want to really make sure that you understand the content of the theorems and know that the IVT is the only theorem. And I'm going to bring back IVT when we talk about the other theorems, but it's the only one that doesn't deal with derivatives. The fact that this is just h of t equals -1 is completely fine. So what does this actually mean visually? So if you look at 1 and you look at 4, you're going to have some function here, and it will cross. It's going to cross. There's going to be something that's going to cross -1. So another way I explain this to my students is that you're basically going to, when you plug in h of 1 to your function and you plug in h of 4, I'm going to tell you right now, one value is going to be above this line and one value is going to be below this line. That's really all it is. Because you will cross at x equals -1. You're going to cross this line on this interval from 1 to 4. So you're going to have a point that's going to be up here, and you're going to have a point that's going to be down here. So it could be here and here, or here and here. So let's do them. So h of 1 is equal to f of g of 1. We're just doing straightforward substitution, minus 1. Well, g of 1 is 3. So we're going to do f of 3 minus 1. And then we do f of 3 is -3, minus 1 is -4. So I know that at 1, I'm down here at -4, right? I'm down here at -4. So that means that my h of 4 should be above this line because I need to cross at this value to get to the point that's up here. So let's check it out and make sure that that's right. So f of g of 4, and be careful that we're doing a 4 here. I have students that always just want to look at this and do a 1, so be careful, we're looking at 4. So it's going to be f of g of 4. So g of 4 is 2 minus 4, and then we're going to do f of 2. F of 2 is 8. 8 minus 4 is equal to 4. So I know it's up here 4. One of the things I also will just say really quickly is the examples that we're giving you guys right now, that these are always the same number, just different opposite signs. That's not always the case. So please don't think that, if you got like a 7 here, you're okay. We just knew from the very beginning of this problem that when we were looking at h of t is equal to -1, right? I now knew that it had to be, one had to be below it, one had to be above it. So when I write this thing out, and this is the last time I'm going to write this, but again, practice makes perfect. So since f of 1 is equal to -4, so that's just telling us that we're starting right here, and that's less than. So this y value is less than -1, which is less than f of 4 is equal to +4. And by the way, another thing I'm going to tell you guys is that this number here sometimes is bigger, and this number here is smaller. So it doesn't always have to be f of a and f of b. It can be f of b and f of a here. So since this is less than -1, which is less than 4, I should do h. That is I don't think they're that picky with it, but I'm not that picky with it in my class, to be honest, but we want to talk about h's. So I'm going to keep that in the video. I'm not editing it out because, that is a mistake that a lot of people make. So since h, because we're talking about the function h, and then h of x or x of t is continuous, right? We always got to say that part because, again, by IVT, there exists a c on the interval from 1 to 4 such that h of t is equal to 1. Okay? So lots of examples here. Sometimes maybe replaying them, it will click for you. Hopefully it makes sense. The last example we're going to do here in this video is a truck travels along a straight track. And we are getting into particle motion a little bit in this particular example. We do cover that in Unit 1 for BC. AB, we don't cover it for a very long time. But a truck travels along a straight track during the time interval from 0 to 30 seconds. The truck's velocity in meters per second is a continuous function. The table below shows selected values of the function. So one thing that I'm just going to give you a quick preview for this. For velocity, if velocity is positive, then you're moving forward or up. And when velocity is negative, you're moving backwards or reverse or down. So when you're seeing that a velocity is negative, that just means we're working backwards. So we're backing up, right? We're in reverse. So it says, what's the minimum number of times that the truck must have stopped? Well, another thing that you guys will learn is that when velocity is 0, that means the particle has stopped. It's at rest. So where's it 0? So this is a very, I think, direct IVT question. This is an IVT question because right now at time equals 0, we're backing up. All right, we're starting back up. Time equals 5, we're still backing up, right? We're backing up at a faster rate, but we're still backing up. At 8, we're still backing up, right? Everything here is negative. And it's a continuous function. It's a continuous function, right? And so now we are going from -5 to 2. So in this value, there's something between 8 and 12. There's something between 8 and 12 where my velocity had to be equal to 0 because I'm backing up, and then all of a sudden at time equals 12, I'm going forward. So this is the first time that the truck had to stop. And then we can go and look at the other ones. It's okay, well, now 2 to 8, we're still going forward. Well, from 8 to -1, we had to, again, go across the fact that velocity was 0. You can even think about this as a number line. We're standing on -10. Then we go to -25. Then we come back up to -5. Then we go to 2. Well, we had to cross 0 when we did that. We're at 8. We have to go back to -1. Well, we've crossed 0 again. And then from -1 to 3, we again had to cross 0. So there are 3 times, the minimum number of times that there are 3 times. Because you could have absolutely went from -25 to 17 and back to -5. We're not given that data, right? So in this particular example, the minimum amount of times that we know of that actually happened here was 3. All right, and so you justify your answer by IVT, and the more justification requires particle motion information, so I'm not going to get into that. But I just want to show you guys another example that this was a calculus example on an FRQ, I believe, where you had to use IVT. So sometimes it's not evident, sometimes clear about it, but again, it's a continuous function. And students were like, well, you said that IVT wasn't derivatives. Velocity is a derivative of, but yeah, but all of this entire problem is in terms of velocity. I don't want to get too much into it because I don't want to confuse anyone right now, but hopefully just knowing the numbering system right here that we had to cross 0 3 times to get these values, at least 3 times, right, is what we have to do. So that's the video on IVT. I hope that this makes sense. And now we're done with lesson number 2. My BC students, you now have about 3 pages of practice problems, and I'm not going to make a video on that, but I have an answer key for you guys, and also I'll obviously be available for you to ask me questions. So I will see you guys when we do lesson number 3.